everyone. I know it's near lunchtime. You must all be a bit hungry, thinking about lunch. Hopefully after this talk, you'll be more hungry. Not just hungry for food, but hungry for more information on this topic. So loss versus rebalancing. Whenever I talk about loss, people tend to wish they didn't hear about this term because nobody wants to talk about loss. But actually, this kind of loss, you could avoid, and you could potentially turn it into a profit. So if you're a liquidity provider, you've never heard of LVR, loss versus rebalancing, hopefully by the end of this talk, you'll get a better idea. You will probably know how to reduce it. So let's get started. First, why do we care, and what is LVR? Some people say that this is bad blood in the AMM system, and I tend to agree. But first, let me quote the original authors who defined this idea in their paper in 2022. They say that LVR is the cost incurred by AMM LPs due to stale prices that are picked off by better informed arbitragers. Well, today at Devcon, I say, this is my quote, that LPs live on an isolated island and they don't know what's going on outside, so they rely on the arbitragers to bring them information. And they pay this unjustifiably high cost, which is what I call LVR. So in this scenario, the LPs are always worse off because they're waiting for the arbitragers to come in and snipe the AMM stale price, make a profit. So whenever the CEX price moves away from the DEX price, it's like leaving cash on the table, right? So at the moment, this cash on the table is only picked up by the arbitragers. Some of it goes to the block proposers, but none of it goes to the LP. So that doesn't seem right, and surely there's something we could do about it. But before we try to tackle this problem, we want to know what's the magnitude of the problem, right? How much LVR is out there? So these are some key questions we're trying to address today. First, how much LVR is out there, not just on Ethereum, but also on Base, Arbitrum, because there are more users using L2. We want to know how much LVR is out there on all the L2s. And secondly, we want to understand if this theoretical value that's proposed by this paper is anywhere close to the empirical value, because the theoretical value is an easier calculation. It will give you a very easy ballpark number of the estimation, right? So if it's close, then that's good news. Lastly, we want to see what are the factors that affect LVR. And this includes looking at different hedging frequencies, looking at hedging on centralized exchange like Binance or Perpetual platforms like DYDX. We also want to look at block time and also the design of the transaction ordering for different chains. These are all very important questions we want to answer and see if we can find ways to reduce LVR. I need to talk a little bit about the methodology here because I'll be referring to empirical versus theoretical LVR, and it's important to understand what these terms mean. So in the original paper, the LVR is defined as a function of liquidity providers' P&L, the rebalancing strategies P&L, and also the LP fees. So on the left-hand side here, we have the hedged LP P&L. So if you're a liquidity provider, you hold WETH USDC, and you don't want to be exposed to the risky assets, let's say you don't want the price volatility of ETH, so you can perform this so-called delta-hedging strategy or rebalancing strategy by selling exactly the same amount of risky asset you hold in the liquidity pool in a centralized exchange such as Binance. So if you do that, you're expected to be risk neutral. You won't be exposed to any risky assets. So on the right-hand side, the only expected return should be your LP fees. But in reality, this is not the case, right? Because we always have some kind of residual left. Because the CEX price is not exactly the same as the DEX price, you will always have something that can't balance this equation. And that residual is defined by the authors of this paper as the LVR. So in my analysis, I reshuffle the equation a little bit. On the left-hand side, this is what I call empirical LVR. You can calculate this using observable on-chain data. And you can also perform a rebalancing or a delta hedging strategy using Binance price. You can calculate everything on the left-hand side. On the right-hand side, you have the theoretical LVR. Here, I'm just showing one of the formula, which is for constant product pool. It's a simple enough equation. You just plug in these parameters. You can calculate theoretical LVR. So the point is that we want to understand if the theoretical is anywhere close to the empirical. If it is, then we can avoid all the hassle on the left-hand side. We just apply this simple formula on the right-hand side to give a ballpark number measurement. Now, enough of the theoretical, empirical, let's take a look at the analysis. So first, we want to know how much LVR, right? We just want to know not only Ethereum, but also Base, Arbitrum. We want to compare the empirical versus the theoretical. We want to compare different hedging frequencies. Here is a chart showing if on an Ethereum with USDC pool, that if you're an LP, you provide liquidity from the beginning of March, and you hold it for 7 months until the end of September, what is your cumulative expected LVR? So this is a loss number, right? Even though it's showing as positive, we want this number to be as low as possible because it's a loss. And the theory goes that if you hedge more frequently, your loss will be lower. And these different lines I'm showing here actually aligns nicely with this theory because you see that 1 minute hedged LVR is the lowest. You're only losing 800,000 USDC. But if you're lazy, you hedge every day, you're losing almost 3 million for the whole 7 months holding period. Just remember that this number is the maximum number because I'm calculating it for the entire liquidity pool, right? So if you're only a single LP, this is only this is the maximum number. You're only getting a portion of that loss, so don't worry. You won't be losing 3 million if you just provide a small portion of the liquidity. You also see some theoretical values here, so that's the 2 dotted lines that's more smooth in the middle. And these are the theoretical formula I mentioned about, and why there are 2 lines. I'll explain in the next slide. So in the original paper in 2022, the authors have made an important assumption. It assumes that there is no trading cost to the arbitrageurs. It assumes that the arbitrageurs trade against the DEX pool, they don't pay any fees. And that's obviously not true. It's not very realistic, right? Imagine you're in a very volatile market. Of course, you have to pay some fee to trade against the DEX pool. So they realized that, and they produced another paper in the next year considering trading fee as a factor in the LVR calculation. So that's why here you see 2 different lines. The line with trading fee taken into consideration gives you a lower LVR because a cost to the arbitrager is a gain to the LP. That's fees you're collecting. So you have a lower LVR here. And we want to compare the impact of this fee feature, and you can see it's around 0.2% of the total pool value. Now let's take a look at Base. Base is similar to Ethereum. It's a priority gas auction. It only has 2 seconds block time, but we expect it to be very similar to Ethereum. So you see here that we have the different hedging frequency. The 1 minute hedging frequency, again, gives you the lowest LVR, only 13,000 USDC loss. But if you hedge 4 hour, it increases to 66,000. Although it's not totally monotonic because you don't see the daily number being the highest here, 4 hours the highest, but we can say that, pretty much in general, we still follow the rule that the more frequently you hedge, the less LVR you get. And again, looking at the difference between considering the swap fee and without considering the swap fee, the difference is similar, 0.3% of the pool value. Now let's look at an outlier, and this is Arbitrum. Why do I say it's an outlier? Because first, Arbitrum is not a PGA, priority gas auction chain. It's a first-come, first-served chain, which means that if your transaction arrives early, it will be executed earlier. And also, its block time is very short. It's only 250 milliseconds, right? So we expect something to be different. And I used two pools here. The first one on the left is the same USDC West pool from Uniswap V2, but unfortunately the pool is not very liquid. It has very few swaps. So if you do the same analysis, you see different hedging frequencies. It doesn't really follow the rule of, the more frequently you hedge, the lower the loss, right? You see the daily hedge actually has the lowest loss. Doesn't really follow the rule, doesn't make much sense. So I thought, okay, then maybe I'll look at a pool with more volume, more swaps. So I found this other pool, Camelot V2, which is also a constant product pool, and I performed the same analysis. And here you see that actually it comes back to the theory that the more frequently you hedge, the less LVR you have. So the 1 minute, you have the least LVR of only 9,000 USDC. And again, we compare the impact of fees. On the left-hand side, you see the difference is about 0.1% of the pool. On the right-hand side is about 0.3% of the pool. So this result is very similar to Ethereum and Base. Now, the next interesting question is, if I'm an LP, I want to perform this rebalancing strategy, this delta hedging strategy, where should I do it? Should I do it on a centralized exchange like Binance, or should I do it on a perpetual platform like DYDX, right? I might want to just stay in the ecosystem, do it on DYDX if there's not much difference. So here I'm showing you the rebalancing strategy P&L. If I hedge every minute, this is the chart on the left, there's almost no difference whether I do it on Binance or DYDX. But if I hedge daily, it seems that I have an edge on hedging on DYDX, right? Because my P&L is higher on this chart. And we found the same for Base and also Arbitrum. So now let's take a look at the empirical LVR. And we also see that the LVR is lower on DYDX. Remember, I said the P&L was higher on DYDX as an LP. So what does it mean here? It actually means the price discrepancies between the DEX on Ethereum and DYDX is actually smaller than the price discrepancies on DEX and Binance. This means that the arbitrager has less of an opportunity trading DEX DYDX. So less opportunity for them to make a profit, more opportunity for you to reduce your LVR. So you're better off doing this hedge on DYDX if you are providing liquidity on Ethereum. But Base, we don't see much difference here. Even you look at the daily chart, it's quite similar. So you can choose whichever you want. For Arbitrum, again, this is very different because we see the other way around, right? This time, you're actually better off just doing the hedge on Binance because the discrepancy between DEX Binance is smaller than between DEX DYDX. So that's what you know. You can choose based on which chain you provide liquidity. The last question we have here is to compare different chains across and see what's the LVR in terms of the percentage out of the total pool value. So the theory says that LVR is a function of square root of block time. So if the theory follows, the shorter the block time, the lower the LVR, and you'd expect Arbitrum to have the lowest LVR. And let's see if that's the case. I have 4 charts here with different hedging frequencies, also including all the chains. And for Arbitrum, I've included 2 pools. One is the pool with low activity, one is a pool with a high activity. But let's just ignore Arbitrum for a second because it's the outlier. Let's focus on the blue line, which is Ethereum, and the red line, which is Base. So you can see for all the hedging frequencies throughout all the 7 months holding period, you almost always have a lower LVR for Base. And Base only has a 2-second blockchain time. So we could say that this follows the theory that the shorter the block time, the lower the LVR, right? But Arbitrum's outcome seems inconclusive because whichever hedging frequency you look at, whichever high activity pool, low activity pool you look at, sometimes it's higher than Base and Ethereum, sometimes it's lower. So we can't make any consistent conclusions here. And this might be because the chain is a first come first served chain, it's different, right? It could also be because the volumes I looked at in these 2 pools on Arbitrum is actually quite low. So the number of swaps are very low here. The US dollar USD trading volume is also very low. You can see the two at the bottom there from the two pools from Arbitrum, much lower than Ethereum and Base. Now we know Ethereum has the highest LVR, followed by Base, followed by Arbitrum. But this is only the LVR from one single pool I'm showing you, right, West USDC. And there are many, many more pools, as we all know, on each of these chains. So imagine if you can capture all of these LVRs. All of this is not a loss. It could be your profit. It could be profit that you can give it back to your user. So imagine the potential you can gain a lot more users using your protocol, using your chain, and the list goes on. Now coming to conclusions. So we've compared a lot of things. We've compared the empirical versus the theoretical. We know the theoretical is kind of similar to the empirical. We can use it as approximation to give us a ballpark number if we want a quick estimation. We also look at trading on a perpetual like DYDX and trading on a centralized exchange like Binance, and the results seem to be very similar if you hedge very frequently. Then we compare the trading fee feature. With trading fee, you have a lower LVR because the trading fee is a cost to the arbitrager and it's a gain for the LPs, so you have a lower LVR. We also compare Base with Ethereum, and Base is a shorter block time. It has lower LVR, so shorter block time, lower LVR. And we also know that the more frequently you hedge, the less LVR you have. There are some inconclusive results from Arbitrum. We don't know if it's because of the first-come, first-served chain nature, or is it because the pools I choose have too low of a volume, not that many number of swaps, right? So these are inconclusive. Lastly, how can we reduce LVR? So as an LP, you obviously want to hedge more frequently. You can reduce LVR by not being lazy. You could also provide liquidity on a pool that has more activities, so your price stay stale for less time. And I want to mention something that I pointed out earlier. So the trading volume and the number of swaps actually play a factor in the LVR. Because imagine if you only have a 250 millisecond chain, but the number of swaps on your pool is only once per hour. So at the maximum, your price update is only going to be once per hour, no matter how quick your block time is, right? So actually, the frequency of the pool, the activity of the pool makes a huge difference. That's why you need to choose a pool with more activity. So as a protocol designer, you want to be thinking about how to internalize LVR and redistribute, capture it at your protocol level and redistribute it back to your LPs. And I think that's what our next speaker will be talking about. They've done something in this kind of design, and I think she will show you some of the practical analysis. You could also improve the real-timeness of your DEX by bringing in some Oracle updates, or even by just charging a dynamic fee. Lastly, if you're a blockchain architect, you might want to think about shorter block time. You want to think about different transaction ordering designs that potentially will increase the opportunity cost of the arbitrager. So first come, first serve chains, or priority guest chains, or any other kind of different design that will help your user to reduce LVR is worth looking into. And that's the end of my talk. I'd like to thank this list of people and also the data providers, Elaine and CC Data, for making this analysis possible. Question?
Thanks. Thanks, Elaine. You can tell how much... The mic's not working. Okay, hi. Yeah, thanks, Elaine. You can tell how much effort she put into the presentation just by the charts. So let's take a look at some of the questions. So the first one, what percentage of LP rebalance their portfolio with a comparable frequency as arbitrageurs?
I would say the LPs are definitely not as professional as the arbitrageurs. So I would expect the hedging frequency at the maximum you could do. I mean, if you can build a bot, you can do it very frequently, right? But if you can build a bot, you're probably an arbitrager. So I actually like to ask the audience, how many of you actually do hedging if you provide liquidity? I only see one hand. Oh, actually a lot more, yes. Yes, so that's good to know. But yeah, it's a lot of hassle. I doubt users will actually use like a highly frequently hedged position, which is why the protocol designer needs to find ways to help the user to tackle this problem.
Okay. So the next one is, how does LVR look on V3 versus V2?
Yeah, so that's something I didn't have time to look into. Well, I had time to look into, but I didn't have time to show you here. V3 actually has a lot more LVR, just because the trading volume is much more, and there are much more activities there. So it's something that's worth looking into for sure.
Yeah. And the next one is, does liquidity concentration increase or decrease LVR?
I think a large part of it is due to the price discrepancies. So liquidity concentration, in some sense, if you have LPs who have these thresholds, right? You have the upper tick, the lower tick. If suddenly the price moves and you suddenly have a lot more or a lot less concentrated virtual liquidities in the V3 pool, your pool's price is going to change, right? Because the less liquidity, concentrated liquidity you have, the more price movement there is. So it depends on how fast the price moves versus the centralized exchange. I think that makes makes more sense than purely looking at the concentrated liquidity.
Okay, on to the next one. Is there a trading fee for hedging activities? I would assume 1 minute hedging will lead to a lot more trade costs compared to daily.
I would say the main fee will be, let's say if you hedge on Binance, I think the fee is around 0.1%. If you hedge on DYDX, this could be lower based on which side of the thing you are. If you're a taker, you pay a fee. If you're a maker, you pay a different fee. I remember the mid price is like 0.03%. So it's actually less cost if you hedge on DYDX.
Okay. How can you explain that the 1 minute empirical LVR is smaller than the theoretical LVR?
Well, the theoretical value is actually in the formula, it's using volatility based on the daily volatility. So that's why. So in the formula, one of the parameters is the price volatility, and in the paper, they use the daily volatility of the Binance price. That's why you get a higher number. And 1 minute, if you use a 1 minute volatility in that equation, you probably get a similar number. Yeah.
Next question. Does execution prices and size of hedging plus how hedges are executed is taken into account?
So the execution price in this paper is just the centralized exchange price, right? So you're assuming you're hedging on Binance. So you look at exactly what the price is on Binance. And the hedging size is just whatever you hold on the LP pool as the risky asset you want to hedge. So in my example, it was ETH. So you hedge exactly, let's say you provide liquidity to ETH with, I don't know, 6,000 USDC, then you'll be just shorting 2 ETH on the centralized exchange price using Binance price.
Okay. So we are out of time for the questions already, but please follow her on X. Perhaps you can answer it there.